Hey everyone, welcome back to the channel. It's great to have you here. In this video, we're going to switch things up a bit. So what's special this time? Right? Take a look at this rendered image. Today, I'll show you the entire process of developing a product from scratch using FreeCAD. So what does that process look like? What exactly are we building? This here is a ring, right? A ring. So in this video, we'll be using the following software: Photoshop, Illustrator, FreeCAD, and, of course, Blender for creating the final renders. This rendered image is actually very important, especially when you're working on packaging design, advertising design, right, or signage, or industrial products. Renders are a key tool for presenting your ideas to a client, for showcasing your work. A good rendering, an appealing final image, can really impress a client. Don't you think? It makes a strong visual impact. All right, let's get into it. This is the final product we're aiming to create today. Let me show you this first. I made this myself. It's a CMF color, material, finishing spec sheet. It's a bit rough. So what is CMF? CMF stands for color, material, and finishing. It's the abbreviation for color, material, and finishing processes. In industrial product design, a CMF document is something you frequently need to create. It's essential, right? Larger companies, big manufacturers, tend to have very standardized and polished versions. Theirs look much more professional. For a product, you'd have a CMF process diagram, right? Showcasing the materials. The 3-view drawing of the product, right? The approximate dimensions, okay? And then the materials it uses, and the manufacturing processes involved. These are the most basic details you need to clearly specify, right? You give this to, say, the appearance designer, and then to the structural engineer. After the structural engineer finalizes the design, it's passed on to the approver for review, right? The approver, based on your, this initial review result, procures the materials listed above, correct? For example, if it's an electronic product, common plastics like ABS, PC, PP, or PMMA could all be possibilities, right? They'll source these materials. If your company itself has a mold factory, right, you'd procure these materials and then start prototyping, right? So today our ring project is a hand-forged ring. For something like a hand-forged ring, using CNC machining or a machining center is obviously unnecessary, right? That's wasteful. A waste of material. For a ring like this, first, the material is 925 silver. It's written here, see? And for its finishing, the surface treatment, well, it's bright silver, right? It's the natural silver color. So there's no additional surface treatment, right? No electroplating for an aged look or anything like that. To prevent oxidation, correct? Because even with a coating, oxidation would still eventually occur. To slow down the oxidation process. And its surface isn't treated, right? At most, it's a hand-forged piece. Then a craftsman would manually refine the edges. Hold on, but there's a carving here. There's engraving. For this engraving, using a base or complex carving isn't necessary. Right, for this kind, it's usually hand engraving. Or a manual stamping, They have those specialized stamps. Right? Specialized stamps. The stamp has various patterns on it, right? And you press it onto the metal. Now, the ring's material. It's like lead tape, right? This is the ring's dimensional drawing. When we actually make it, we don't have to be super precise. This is the vector pattern for the ring. The leaf pattern. The product is called Qing Feng Zhangyi. So, it's a vector graphic leaf, see? And here, we engrave this marking, right? 1925, denoting the material, and behind it is the serial number. For a hand-forged ring, the tolerance range isn't really something we worry about. We don't need to stress over precision, right? We'll adjust it as we go. These are the orthographic views of the ring. Okay, now let's look at the box packaging. For the box, we're using a pretty classic style, a lid and base box. This type of box is very common. You see a lot in product packaging. In the middle of the box, there's an insert made of EVA foam. This EVA foam insert is where the ring sits, right? And as for the box type itself, the material is corrugated paper. And the color is this Pantone. Usually, this kind of printing uses a Pantone spot color. That spot color is black 7U. This one is a matte finish. It's a matte color, while something like black GC would be a glossy color, right? A bright color. Then, over here is the silkscreen printing part. This is the silkscreen area. This silkscreen is a gradient print with silver foil stamping. A gradient print, you see. So now, both our form, right? Both the ring and this silkscreen design are finalized, right? Next, we can finally start working on it. Drag this drawing into the software. Now this drawing, I can't conveniently provide it here. You can just take a screenshot of it. Pause the video and take a screenshot. Just screenshot it. This drawing is something I made myself. So just grab a screenshot for yourself. After that, we import the image, and then we can jump right into it. Let's start from the very beginning, from scratch. Let's clear this document and begin again fresh. Create a new one, right? A new document. We could start with a vector graphic first, or go ahead and model the ring band first. Either way works. So what I'll do here, is not use this red plugin. I'll just draw a ring band from scratch, okay? This is a pendant, right? This is the pendant part, right? So the outer diameter is, say, 23. The diameter of this outer circle is 23. Let's draw another one, an inner circle. For the inside, let's make about 19.5. That should be good. 19. As for the extrusion height, let's set it to 13. Because we'll need to cut into it later, right? So, let's create a reference point here. Right, at a reference point. Let's sketch something like this in the front view. To create a radius cut like this, the radius size is a 135, right? Okay, let's assign a datum plane to it. YZ. Let's get this started. The operation will use these two guide curves. Let's reference them. So we have our two guide curves referenced. With those referenced, we can draw an arc. An arc segment like this, right? We'll constrain it here. Constrain it on the axis. Make these 2 points horizontal. Then give it a radius of 135. A bit tricky to control. And then constrain a horizontal distance of 50 here. That was too big just now. We just need to ensure it cuts through completely. The rest doesn't matter. Don't worry about the rest. Draw a line, right? This line is just to ensure the cut will go through. Right the spot here. Vertical, make it vertical. Vertical, and also make both sides equal. Yes, both sides equal. Next, for this part here, if we want to fully constrain it, just assign any arbitrary distance, right? Just give it some distance here, doesn't matter what. Let's apply a dimension constraint here. It's roughly around 9.5. That's how we constrain it, okay? As I mentioned before, don't follow the drawing exactly, because this is for hand-forged jewelry. For handcrafted pieces, the exact dimensions aren't critical. Don't worry too much about them. All right, that looks about right. Good. Now let's cut this part away. Cut it. Make sure it cuts through completely. Complete cut through. So we end up with a shape like this, right? This is the form we have here. So this is the shape we have, right? And this ring we're making, as we mentioned before, right? It's a hand-forged piece. Since it's hand-forged, We don't need to worry too much about these rounded corners or edge finishing, right? Later on, for this hand-forged piece, the artisan handling the post-processing will take care of it, right? These sharp edges, these sharp corners, they'll definitely need to be softened or rounded off. Isn't that right? And it's not like those conventional electronic products either, right? Their surface treatments are so complex. Take this, for example. Ops plastic, right? ABS. You have to consider things like surface, painting or spraying, sandblasting, electroplating, right? This isn't that complicated. It's pretty straightforward, right? All right, so we have a basic band shape. With the basic band done, what's the next step? Next, we import the design drawing. Let's bring in this drawing. Let's see. Where's the drawing imported to? Double-click on it. Import it onto this XZ plane, right? Let's adjust its size. Make it about 20 by 20. We're going to trace this vector graphic, right? Now, let's adjust its position on the y-axis to bring the vector graphic into view. Set its opacity to 50%, right? That makes it a bit clearer to see, right? And it won't interfere with our tracing. Open a draft workbench. With draft open, we'll use this image as our work plane, right? Use this image as the work plane. Next up, we'll move this image back a little further, okay? Move it back by 1 millimeter. Use the Bezier curve tool to sketch out the basic shape of this pattern. See, like this? This part is pretty straightforward, right? It's quite simple. We're outlining the same basic profile here. Okay, just draw the lines out. All right, I'll speed up this part a bit. Good. So now our vector shape, right, is done. Next, I'll group this vector shape, okay? Just drag it into a group. Then we'll use the pad tool in the part design workbench to create a solid surface from this sketch. For each element, we build them one by one. All right, so now the surface is created. Let's hide the construction lines. Now let's also group this set of surfaces, right? Group the resulting surface geometry as well. Drag it into the group. So we have a surface group like this. Make sense? Next step, switch to the draft workbench. Take this group of surfaces, and what we'll want to do with it is drag and drop it onto our working plane. Drag it onto the plane. Now this surface here, we need to rotate its angle a bit. Adjust the rotation. First, select this face and create a duplicate of it. Then rotate the copy, like so, 90 degrees, right? Okay, next, we'll position this copy to align and fit with this other surface. What are we doing next? The embossed pattern. Right, we're creating the engraving. Select this object and click Move. We'll snap to a point, okay? At this point, let's turn off the auto constraint plane. What view are we in now? The front view, right? Front view. So in front view, we click on this face to move it. Oops, wrong view. Click on it. Let's move it here. Snap to this point, okay? When snapping here, make sure snap to point is enabled. Point snapping. Let's say we snap it here. Right? Next, we can fine-tune it further. Over here in the data panel, the location property here, we can adjust it precisely. For example, adjusting the spacing in the Y direction. Right? Adjust the spacing to about this size. Set here. Based on the size of this vector graphic, we could actually adjust it more. If someone feels it's too small, they can make it a bit larger. But to ensure it doesn't get too large and exceed this boundary area, I'll keep it about this size. Yeah, this size is about right. Now, Let's turn off this grid. Go back to the Part Design workbench for the surface projection. All right, time to project the surface. First, position the camera/view. Add the projection surface. Add faces. 1, 2, 3, 4, 5. Those are the faces, right? Let's project them onto it. After projecting, what's next? The extrusion height doesn't need to be that tall. It's just to preview the effect. Write the depth of the solid. How much should we offset it inwards? Let's offset it inward by a depth of 0.15. That's about good. Don't make it too deep. Not too deep, okay? Confirm. Now, continue back to the draft workbench. The draft workbench. Change the view to the top plane. Click on this projected shape and apply a polar array to it. Enable center snapping. Turn off point snapping. Let's make 10 copies. Right, for this location here, we need to snap to its center point. There, good. Polar array. Circular pattern. Right, let's hide this main body. Hide this main body. So next, go back to the Part Design workbench. Back to Part Design. What do we do with this solid and this one? We'll prepare for a Boolean cut. A Boolean cut. All right, at this point, the cut is complete. After cutting, let's check for any broken surfaces, right? See if there are any broken faces. Sometimes, broken surfaces can occur. So, let's check, right? Let's have a look. See if there are any broken surfaces. If not, that's best, right? If it's broken, we'll find a fix. That's the general idea. Yeah, that's how it is. Next up. The engraving here works the same way. We engrave the text onto it. Same principle, right? So here, hey, let's create some text. Let's create some text. Right, how do we create this text? Right-click on this. Shape from text. Right, let's do it. We'll define a position for it. Let's snap to its midpoint, right? So, generate a text string at this position. What should this string be? S925. That's the material mark, right? Set the size to, say, 0.25. Select a font file. Here's the text it generated now. I see it's tilted. See? Let's change its axis. Move it to about the right position. Then we can adjust this here, the tracking or letter spacing. Let's adjust the spacing, maybe 0.15. Font size 0.15. A bit smaller. Yes, smaller. Then, we'll use the Project to Surface tool. The projection surface function is for projecting a surface onto something, right? So we project this face. Add this face, and add the font's face. Be careful not to cut through too much. Set the cut depth to, say, 0.2. 0.2. The extrusion height doesn't need to be that high. Let me show you. 0.2 is about right. Even 0.1 is fine. Let's go with 0.1. Then we use this, the text object and this solid object, to perform a Boolean intersection. We'll do another cut. There. So now, the engraving is complete. Next, we'll take this object and put it into the solid body. Create a clone copy. Hide this original one. Activate this copy. Now for the fillets here. They're not really necessary. We can skip them. But the outer edges of the ring band, let's add a fillet for aesthetics, just to make it look nicer. Let's do that. Maybe a 0.5 radius. Right? Let's try 0.5. Actually, 0.5 looks too big. Let's have it to 0.25. Just a slight edge break is enough. The precise edge finishing will be handled during post-processing, right? So this is the result we get. Let's apply a quick material shader in here to preview the final look. So the final preview effect looks something like this. Yeah, notice the curves on these two sides. They were cut out, so their curvature is actually different. This part here is concave, since it's designed as a pendant. So let's not worry about all that too much, okay? We don't need to overthink it. The main body part. That's created. So, what are we creating next? We're creating the box now, right? Creating the box, so we'll start a new body for that, right? We'll do it within the same project file. Go ahead and start a new body, right? We'll use this loop of edges for a copy geometry reference. For referencing purposes, right? So using this copy geometry, we can determine a center point. Specifically, it's centroid. Right? Right? We use this centroid to create a new datum plane. What's this datum plane for? To sketch the shape of its packaging box. Now for the box shape itself. Well, you usually don't have to draw this from scratch, right? But if you want to save some money, whether for personal or company projects, it's useful to know this stuff, right? If you know packaging design and, do some 6 design or things like that, it's actually a big plus. A definite plus, right? But for standard box types like this, you usually don't need to draw them manually. Online, like on sites such as Bao Xiao He or similar, there are tons of ready-made templates. You can just grab one, right? The die-cut layout is already drawn for you. They have everything. Let's sketch a box. Let's say the box is 50 by 50 millimeters, right? That should be enough to hold this. Honestly, that might be too big. Even 35 by 35 would work, right? Make it a bit smaller, more compact and refined. That's fine too, right? Let's make it symmetrical. This is the base of our box, right? This is the base part. And this, since it's a lid and base style box, right? So for this section here, let's tackle one part first. The EVA foam insert in the middle, right? Let's raise it by 10 millimeters. That should be more than enough, right? Now, let's check the size of this ring. What is it exactly? Right, let's measure it. Go back to this solid body and measure it. I'd estimate it's around 8 point something. Oh, hold on a sec. This point to the point at the bottom, right? 6.66. So we'll mill an 8 millimeters and a 9 millimeter slot. That'll be plenty, right? We can just press fit it in. For something like a box assembly, you don't need to be too precise, right? The zero clearance fit is totally fine here. It's not like some highly jingmi de chanfi precision products where you need to leave specific assembly clearance, right? Otherwise you might get interference. A little interference here is okay, right? Zero clearance is perfectly fine. Now for this, boss. Let's look. See, it's inside here now. Inside here. So this boss feature will mirror it using plane symmetry, right? Based on bottom face. Then, for the ring itself, we'll just create a cavity here. An 8 millimeters hole will do, right? Just make an 8 millimeters hole. And its inner diameter is 23, right? 22 or 23 would both work. A snug fit is fine, right? Because the foam is elastic. Isn't that right? Here, let's just create a sketch directly on this face. No need for a datum plane, right? For a small, simple part, with few steps, the datum plane isn't critical. So here, 22.5, right? Press it in tight to ensure it won't fall out. We'll make it 8 millimeters deep. An 8 millimeters deep cavity. There, now is this piece inside? See? It's inside. We'll deal with this during rendering later. We can just pull and adjust this part then. There's no need to add fillets here. Fillets aren't necessary. This is just, this area for the interior foam. It's just the area for the foam insert. Right, this is the area for the foam. Next, let's create a new solid. Create a new solid and copy this geometry, right? Copy the geometry of the foam's bottom surface. Use this geometry to create a datum plane. The datum plane is also created with 0 offset. Right, with 0 offset. We can directly use it to pad/extrude a feature. Right, so we can use this face directly for padding. Right, and then let's flip the direction and see. This should be 20. This is 20. Now, for this part with the 20 millimeters dimension, we need to shell it. We need to shell this part. Shell it with a 1 millimeter thickness, right? A 1 millimeter thickness outward. Let's make this visible. That's what it should look like, right? For this bottom cover section down here, it's the same process. Copy its geometry. Copy the geometry. Then directly pad/extrude it. Pad it. Extrude it downward until it meets this face. Oh, wait. I copied the wrong thing. This. Hide the other part and copy this geometry. Copy this geometry and then pad/extrude it, right? Extrude it 20 millimeters, right? It's flat. It's flat, and it's fine to bring it down a bit further, right? Ideally, it should fit flush. Fit perfectly flush. Because the foam is elastic, right? Since the foam is compressible. An extra millimeter or 2 doesn't matter, right? Especially since it will be shrink wrapped later. You can press it down firmly, no problem. It's fine. Really, it's okay. Let's go with 20. This 20 here means the pull out for this part goes inward along the thickness, right? The 1 millimeter thickness is facing inward. See? Yeah. And then this foam insert, right? Look, the foam. For the ring, this ring. Could sit a bit higher, that's fine. This part can also come up a little. We can fine-tune that later in the model space. Just adjust it bit by bit. After all, we're building everything up layer by layer, based on this central reference point, right? And since it's a perfect zero clearance fit, we don't really need to worry about these tolerances, you know? No need to worry. All right, that's how it looks. Next. I won't even add fillets here, right? I'll skip that for now. Basically, that's it. Take a look at this wireframe view. So we'll export all these components. Export them out. We'll export them out because we need them for rendering, right? Regarding rendering software, what options do we have, right? One is called Keyshot, which can directly render the STP file. That's the first option. The second, you can use the open source Powerhouse Blender, right? Well, I'm using Blender here for rendering. So we need to export as OBJ, right? Yeah, including this EVA foam insert, everything goes in. Got it. Let's export it. Export it. Make an OBJ file, right? The ring packaging box, right? For the precision, it doesn't need to be super high. You can max it out if you want. Maxing it out will just make it a bit smoother, right? Rendering at a higher sample count gives you a bit more detail, right? There's a die cut line on the box. This is the die cut area. The die cut area. Next, I'll take this die cut line and drag it into Photoshop for some cleanup. We can discard this wireframe view. This is the actual die cut part. Copy it. Texture. This is our silkscreen layer. So this is the silkscreen artwork. Now for this silkscreen layer, I'll just export it directly as an image with a transparent background, because we're going to use it for rendering. Right, for the 3D render. A bitmap is fine. Bitmap. But if you want this for actual printing, you need to convert it to CMYK. Or sometimes people set it up as a spot color channel. Right? So this silkscreen layer, the silkscreen for the packaging. Packaging silkscreen. I'll then bring this silkscreen into the rendering software. Okay. All right, let's launch the software. Let's import the OBJ file we just made. Which one is it? This one, right? After importing, the software will automatically separate the parts. It does the splitting for you, so no need to worry, right? Now, since this is just for rendering, you can freely adjust the size and scale. It's fine. Let's position it at the world origin. Center it in the scene. All right, let's adjust this here. This is the outer packaging box, and this is the EVA foam insert area. This part is the foam insert. Let me adjust it. And this part here is the recess for the ring. Let's bring it up a bit. It sits right here, see? Now I can turn on snapping. With snapping on, it'll be positioned more accurately. Let's separate the lid's UVs. For this UV part, let's UV it and unwrap it. Later on, for this area here, let me check this spot, this region of the box. Let's go ahead and separate out the UVs for it. Yeah, split off the UVs. Or we could just do a UV project on it directly. Actually, let's just use Smart UV Project. Saves time. Smart UV Project. Let's look at the UV editor. Whoa, it's completely shattered into pieces. Totally fragmented. This face, that face. Okay, this face here. Which image are we using for this texture? It's the one for our silkscreen printing, right? The transparent layer for the silkscreen. Then change this mix nodes blend type to multiply. All right, connect the color to socket A and the result to socket B. Hold on a second. The mix result is set to multiply. The texture we've applied now looks a bit, a bit distorted, right? Yeah, distorted. First, let's fix the UV mapping for this in the editor. Straighten it out. Right, get it aligned properly. Let me recut the seams. Do a fresh seam cut. It'll give a warning now, saying failed to pack islands. But that's fine. Doesn't matter. Okay, so this area here is where the seam is, and then we'll take all these regions on this side. We don't need these areas. Just move them away. Move them out. It might look a bit messy when moved, but it's okay. Away, away. Move them all away. This is my lazy method. Switch it to clip, right? There, that's it. Let's go back to the UV editor and check again. Oh wow, oh wow. There we go. That's how it looks. Like this. Now let's go back to the left-hand side panel here. Let's adjust it a bit more. Right? It's black, right? This packaging is black. This could be made a bit smaller. Center it. Now let's lift this packaging element up. Move it to the side. Make some fine adjustments. There we are. It has a kind of indented effect. As for this spot here, for this area here, we'll do the same. We'll give a black foam part here. We can simulate this foam part by using a noise texture to simulate it. So we'll use the object, and then use a color ramp to tweak it. Give it a displacement map. Its base color is black, yes. Actually, a darker black. And the EVA foam itself has a bit of roughness, right? Just keep the default for that. It should have some reflectivity. Don't worry about the rest. Leave the rest alone. That's it. Alright, so this EVA foam is also simulated. For the detailed settings in this part, we can fine-tune it a bit more, right? To make this EVA foam appear finer, more detailed. Yeah, a bit finer. Now, let's set up the material for the ring. Since it's supposed to be 925 silver, right? We'll give it a metallic material. We'll turn up the metallic value. For roughness, let's set it to about 0.25. Because it's a polished silver, right? A bright silver finish. So this metallic shader basically simulates that, right? Now, if we wanted to simulate a bit of these oxidation marks on the silver surface, can of course be simulated as well. Yes, they can be simulated. Using the versatile noise texture, we can simulate that effect. Take this converter node and connect it to the roughness input. Let's adjust the scale for more detail. Right? That gives us this kind of look. We can also add a bit of distortion here, so it appears less uniform, right? Besides that, we can use other textures to control it. Here, like this. Just to be clear, this isn't a full rendering tutorial. But let's add some detail. Bring out the details a bit more. The scale depends. Just adjust it until it looks right. Alright, that's about right. Like this. Next, let's set up a background, okay? Set the background. Let's add a plane. That acts like a large, even light source. A reflector, right? Place a reflector here. Turn off snapping. Auto smooth. And then, looking at this reference render, the back panel here has a subtle texture variation. Yes, there's a texture change. Let's add one for ours too. Let's give it a similar textural variation. Okay, add a texture. A wave texture, for example. Something like this. A slightly cyan-leaning color. Right, that provides a nice effect. Yeah? let's move it forward a bit. Next up, let's set up the lighting. Lighting is on. Now, add a camera. Frame a shot like this. Shoot from this angle. Just a quick framing. Let's adjust the camera's focal length. Add a bit of perspective. Frame it roughly centered. For a shot like this, we're basically taking a picture, right? This is what we call setting up the camera view. Makes sense? Now, let's move on to the lighting setup. We'll set the initial sampling to a lower value. Say 1000. If your system's denoising performance isn't great, don't enable it. It can be quite demanding. My own computer isn't the greatest, so I'll leave it off. Let's add some light. This is a path tracing renderer, which is physically based. If you're interested, you can look up more about path tracing renderers. Path tracing. For the ceiling here, how should I put it? Let's add a soft light. The purpose of this soft light is to, to reveal our products, general shape and outline. The main job of this light is, to highlight the details. You see? Focus on the details. I plan to use 2 lights to showcase it. If I increase the light's range, I also need to bump up the wattage. Let's increase it. Alright, let's adjust the camera position a bit. That gives us a much better lighting effect, right? Actually, this main light could be a bit stronger to better define its silhouette. To emphasize the silhouette, should we adjust this background panel a little? Let's brighten it up a bit. Right, this is a full shot. Not a close-up of the ring. No ring close-up. This is the overall scene. See? Once we're happy with everything, right? Then I can start the render. Starting the render. Okay. Due to time constraints, rendering the full image completely would take way too long. So, I'm going to skip ahead here. This is the final rendered image. Honestly, I didn't handle the details of this part very well, right? For example, the textured pattern on this ring, right? It looks more like a piece after pickling. Doesn't it? It resembles the look after pickling. You see? So, after the renderings are done, we can give them some final touches, right? Like adjusting the contrast, the brightness, right? All right? Then you can show them to your client. Okay. And that's the overall process from 3D modeling and sketching drafts to preparing the silkscreen artwork and finally to rendering. Of course, this is just a very simplified overview. A complete product development process is actually quite complex. It requires collaboration among multiple people, right? Only then can a perfect product come to life. All right, that covers everything for this episode. If you enjoyed this video, please give it a like, comment, and subscribe. Thank you all, and see you next time.